Hi, friends. Trying to do these slides take two, so I'm hoping that you can see them now. Um, let's give this another shot. Trig Identities. You can follow along in your textbook, chapter 14, section 1. Chapter 14, section 1. Um, yeah, so hopefully today I will figure this out. Thanks for your patience with me. For the anti-set, draw a right triangle. If I tell you that sine of theta equals 3/4 and that the graph of the triangle is in quadrant 1, what information do you know about the triangle? What information can you find about the triangle? Find all that information now. You can go ahead and pause the screen, pause the video, and we can pick up with that when we come back. Okay, so here is that triangle. So what we know is if the sine of theta is 3/4, then that means the opposite side is 3 and the hypotenuse is 4. So using the Pythagorean theorem, we can say 4 squared minus 3 squared equals a squared. So that's 16 minus 9 equals a squared. So the square root of 7 equals a. Okay, with that information, then we can go ahead and find all of the other trig values there as well. So we could say that cosine of theta is √7/4. Tangent of theta is 3/√7. When we rationalize that, that's 3√7/7. That gives us that the cosecant of theta is 4/3. The secant of theta is 4√7/7. And cotangent of theta is going to be √7/3. So that's a lot of information that we can find. We could also utilize that information knowing those lengths to try to elucidate what theta is using our arc sign. So we could always pop into our calculator and we can say second arc sine of 3/4 is I gotta make sure I'm in the right mode. Make sure you're in the degree mode. And that gives us that this is about 49 degrees. And then if we wanted to find the other angle, this one would be roughly 41 degrees. So that's solving that triangle there. Today we're going to be able to verify our trig identities. So we started out with level 1 information yesterday. We're going to take that and apply it today with level 2 information. Homework, there is Khan Academy Use the Pythagorean Identity, and there's Math Excel, the 14-1 homework. Both of these are for grade, but remember, I will be very gracious with the grading on this time. Please try not to spend more than 90 minutes altogether working on this, and please absolutely get up and take a break every 30 to 45 minutes. Okay, so verifying an identity. So you should have a list of things that substitute in for your that you can substitute in for one of these identities. So we know things like tangent, for example, equals sine over cosine. Okay, we have all of these relationships that we can use. So what I want to go ahead and do is I want to take a look at this particular example. And whenever we're proving an identity, we want the left side to be equal to the right side. So I kind of cement this right side as it is. I don't touch it. I know that that's my goal, and I'm trying to turn this left side into this right side. So I'm going to start with this relationship here that I identified from my notes, and I'm going to substitute in sine squared theta over cosine squared theta for tangent. Okay. And then I have a fraction that I want to add to 1. And in order to add them, I need to have a common denominator. So I'm going to turn 1 into cosine squared theta over cosine squared theta because that's equivalent to 1 and has a common denominator to the sine squared theta over cosine squared theta. So that gives me cosine squared theta plus sine squared theta over cosine squared theta. And I know from yesterday that cosine squared theta plus sine squared theta is equal to 1. So I can substitute 1 in there. And I know from my notes yesterday that 1 over cosine squared theta is secant squared theta. So I can substitute in secant squared theta, and I have proven that identity. So here I'd like for you to practice, and then I would like for you to pause the video while you give it a shot, and then I will show you how that one works. Okay, verifying this identity. I'm going to take my relationship, and I know that cotangent is cosine squared theta over sine squared theta, and that equals cosecant squared theta. And then I'm going to turn the 1 into sine squared theta over sine squared theta because it has a common denominator as my other fraction, and it simplifies to 1. So then I can add them together. And I know that sine squared theta plus cosine squared theta is equal to 1, so I can substitute that in. And from my notes, I know that 1 over sine squared theta is cosecant squared theta, so I can substitute that in. And I have proven that this is a true identity. Here's a couple more for you to practice. I want you to go ahead and pause the video and then come on back and I will show you how I solved them. Okay, so what I did here is that for tan squared theta, I substituted in sine squared theta over cosine squared theta. And now you can see that I have fractions. Oh, there's no denominator here. Sorry about that. Now I have a fraction that I want to add. And so I need to make common denominators for that. So I'm going to turn sine squared theta into sine squared theta times cosine squared theta over cosine squared theta. And I want to keep that right side exactly as it is. Okay, now I can add these together or really subtract. So sine squared theta minus sine squared theta cosine squared theta all over cosine squared theta. And for the interest of time, I'll just say I'm keeping them the same. And I notice that these both have a factor of sine, so I'm going to pull sine out as a greatest common factor, which leaves me with 1 minus cosine squared theta inside over cosine squared theta. Now, a little bit of math magic. If I have sine squared theta plus cosine squared theta equals 1, I can subtract cosine squared theta on each side, and I would get sine squared theta equals 1 minus cosine squared theta, which is this right here. So I can substitute in sine squared theta again for that. And then I can pull this apart into two fractions. I can have this as a fraction, and really that's times 1, and I can make that a second fraction. So sine squared theta over cosine squared theta is tangent squared theta, and sine squared theta over 1 is sine squared theta, and that does equal the right side. So that identity is verified. All right, so then this next one, I can see that secant squared theta is a common factor right away. So I'm going to pull the secant squared theta out, and I get 1 minus cosine squared theta. And I know that 1 minus cosine squared theta is equal to sine squared theta from that little trick I did on the last slide. I know that secant squared theta is 1 over cosine squared theta. So I'm going to substitute that in. And if I multiply, I get sine squared theta over cosine squared theta. You might feel like it's enough to just leave it like that, but the right and the left side are not identical. We do want the right and left side to be identical, so this would be your final answers to actually substitute that tan squared in. So simplifying is a little bit harder in the sense that we don't have that end goal. We don't have that right side that's telling us what we want to get to. But it's the same idea where you're substituting stuff in and rearranging to make them as simple as possible. So let me go ahead and show you how I might do this first one where I have cosecant theta times tan theta. Well, I know that cosecant theta is 1 over sine theta. And I know that tangent theta is sine theta over cosine theta. You can hear Pearl in the background. When I multiply these two rational expressions, I get 1 over cosine theta, which I know is secant theta. And so that would be our simplified version of that expression. Okay, so I didn't know that secant was my end goal, but I could do my best to make this as simple as possible, and you can see that secant theta is more simple than cosecant theta times tangent theta. So you can either pause or you can go ahead and try this next one on your own. If you pause the video, I'm just going to go over it when you come back. Otherwise, I'll go over it now. So I know that secant theta is 1 over cosine theta, and cotangent theta is cosine theta over sine theta. The cosines cancel out to give me 1 over sine theta, which is cosecant theta. And that's my simplified expression. Your practice for today is the Khan Academy to use the Pythagorean identity, which is for a grade, and then Math Excel 14-1 homework, which is for a grade. Remember that I will be very gracious with the grading on those, and to please try not to spend more than 90 minutes, including watching this video today, working on this. If you have questions, I have office hours today, 2 to 4. I'll also have office hours on Thursday, 1 to 3. Please pop in. I'm happy to help you. I would love to help you with anything that you need. So please do post any questions you have to your attendance question today, and don't forget to sign in. So hopefully we can verify trig identities now. That was our objective for today. And just for you, in your notes, you should identify the first step in proving an identity so that you can have that as you move forward. I'm hoping that this is going well. This is super important stuff for next year, and I'd be remiss if I didn't prepare you for that. So hopefully it's going well, and if not, hopefully I see you in office hours, or please send me an email.